Geometry Section 1-4. And surprise, it's more vocabulary. I know I apologize for that sort of in the last video, but it's going to be a little bit more of that today. I promise you more dynamic material is coming. And you say, man, this class really starts boring. Well, if you were here and we were full time, you'd find me to be entertaining, I hope, and I crack jokes and stuff. But I'm trying to keep these videos shorter, so I'm not making too many jokes. But please bear with me on this. We're going to get to some more dynamic material soon. And again, I did make this available in the class drive if you want to go print it, access it that way, or you should write this down. And we want to define what a segment is. We actually used segment in the previous lesson, and now we officially define it for you. And it's basically just part of a line consisting of two endpoints and all points in between. And then in parentheses here, I show the symbol, right? That symbol with no arrows over the top, just that bar, that means segment. And the way we should say that is segment AB. Ray. A ray is part of a line consisting of one endpoint and all points on the line on one side of the endpoint. Okay. Now it's a little bit small there, but that's an arrow right there. This is pointing to the right. When you denote a ray, and by the way we would say this one is ray AB. There should be an arrow always pointing to the right, never to the left. The first letter should be the endpoint, and the second letter should be is there to indicate direction. Okay, so on whatever this line is, there's an A and a B, and this ray. Okay, so I'm using the right words here. Wherever this line AB is, there's a ray that is part of the line. It starts at the point A and goes in the direction of B and past it forever. Okay, that's the set of points. Different from a line. It's only part of a line. Off that, then we get opposite rays, which two collinear rays, what they are, two collinear rays with the same endpoint. Together, they form a line. Okay, so if we have ray AB, and that's going to, let's just imagine a line in front of you that's going to the right and to the left, and A is kind of in the middle of your page, and B is off to the right. Well, there must be another point, let's call it C, that's on the opposite side of that, on that line that's to the left, and ray AC would be opposite ray AB. Notice they have the same endpoint because I'm using the letter A first. Lines that do not intersect may or may not be coplanar. Lines that do not intersect may or may not be coplanar. Now, that might be news to you because you coming out of the class that you were probably in last year, either algebra or pre-algebra, when you graphed parallel lines, they were in the same plane. You graph two parallel lines, they're in the plane that was known as the coordinate plane. But you got to think about this in terms of three-dimensional space. And sometimes they are coplanar, but they do not have to be. And the way that lines can be is they can be intersecting, or they could be our next two words, which would be parallel. Parallel lines are coplanar lines that do not intersect. Okay, so that doesn't fit into the statement above with the stars, but this next one does. Skew lines are non-coplanar lines. Skew lines are non-coplanar lines. They're not intersecting and they're not parallel. If you think of the practice sheet that was on the previous lesson, we saw two lines that were not parallel and they were not intersecting. Those are skew. When I show this in front of my classes, I say, hey, look here, I hold my arms out in front of me and they're not touching each other and they're not parallel. And I say the lines that contain my forearms here, these would be skew. I always feel like I'm doing the robot when I do that, though. And then one more vocabulary piece is parallel planes. These are planes that do not intersect. And if you just held two pieces of paper up that are parallel, that would model it for you well enough if you understand what a plane is from our previous lesson. Okay? Now, a little bit of notation here. This says line AB is parallel to line EF. This symbol right here is parallel to. So here you have a line. We're using the line symbol. Here's another line. They're parallel. And these are then the words that I just said. Line AB is parallel to line EF. Okay? Now, to some examples. This says name the segments and rays in the figure. Okay? Now, here's the thing. I know that I spent some time in the previous lesson talking about the fact that it doesn't have to be drawn for it to exist. And in fact, there is a segment AC that exists in this problem. This question is not geared towards that, though. When they say in the figure, what they mean is drawn. Okay, so just to keep it simple in this case, and I know that's a little bit contrary to something I said before, but it really has to do with context. It has to do with the fact that they said in the figure, they're talking about that we have drawn, you know, what you see in red. And so we'll just name those. And the segments would be segment AB and segment BC. And please use the word segment when you're saying it, and use the symbol when you're writing it. Segment AB and segment BC. Now, what if I flip the letters around? Any problem with that? Segment BA, wouldn't that be the same thing? Yes, it would. What if I flipped around C and B? That would be the same thing. Because it's not about the name, although being able to name them is important. It's not about that, whether they're the same or different. It's about the points that they represent. Segment AB means you start here and you end here, and you have all these points in between. That's the segment. The rays, on the other hand, that are being shown here, they both have endpoints of B. This would be ray BA, right? Because it has the endpoint here and it's going in this direction, and also ray BC. And again, the arrow should always point right when you're naming a ray. The endpoint should come first. The second letter denotes which direction you're going, right, from the endpoint. That's exactly what you see there. Next example, use the figure below. Name all segments that are parallel to AE and all segments that are skewed to AE. This is a situation where I usually take 7 volunteers to get people going in class, and they give me several different things. I don't have that option this time, but notice that segment AE is in red. All the ones that are parallel to it are in blue. So segment DH, segment CG, and segment BF are all parallel to segment AE. Okay? And because, and just to tie it into where we're trying to go with this, is that they are in the same plane. Segment AE and segment DH are in the plane that contains the left side. Segment AE and segment CG are in the plane. Even though that plane's not drawn, there would be a plane that would cut through, hard to show, but basically this would be the section of it right here. That would be the same plane, and then also segment BF, because AE, segment AE and segment BF do share the front face. Now, all the ones that are skew are in green. Notice that the green line segment DC, it doesn't intersect AE, and it also is not parallel to it. So that's a new word. We need a third word. You got intersecting, you got parallel, and these are skew. Segment CB, same thing. Segment FG and segment HG, these are all skew. The black ones then are intersecting, right? So you have 3 different things going on. The black ones are intersecting the red one. The blue ones are parallel to the red one. The green ones are skew. One more example. Identify a pair of parallel planes in your classroom. You're not here, but I'll tell you that thankfully the ceiling and the floor are parallel. The east wall and the west wall are parallel. The north wall and the south wall are parallel. I have boards on all 4 of my walls, whiteboards that is. The back whiteboard is parallel to the front whiteboard. The screen that I have is parallel to the back whiteboard. The desktops, we always talk about this because the desktops do kind of tilt back towards the student a little bit, most of them anyway. So that technically not parallel. It's usually I get a student who will give me that example, but close, parallel planes. Okay, one last thing. There's always confusion when it comes to segments and rays and when they're the same and when they're different. So I just want to give you a quick example. When we say line AB, on this example here, on this line, when we say line AB, line AC, line CD, or line DA, or you could list some more, as long as you're using a combination of 2 of these letters, that's all the same line. Line AB is the line that contains these 2 points that goes infinitely this way and infinitely this way. Line AC is the line that contains these 2 points and goes infinitely this way and infinitely this way. Those are the same set of points. So yeah, that line has multiple names. I guess more restrictive, segment AC, so I'm just picking, that's just an example. A is an endpoint, C is an endpoint. there would be no other way to duplicate that other than to just flip the letters. So yeah, segment AC and segment CA are the same segment, and that's it. Ray DC, so now I'm picking an endpoint and going in the direction of C. That means that it's the set of points that starts here and it goes infinitely in this direction. Ray DB does exactly the same thing. It starts here and it goes in this direction. Ray DA does the same thing. So again, these are the same. They're named differently. That's just because there's multiple names for this ray. That can happen. However, ray DC that goes this way is different from ray CD that starts at C and goes this way. It's a different set of points. You follow? Ray DC starts here and goes this way forever. Ray CD starts here and goes this way. That's a different set of points. Okay, well, thank you again for tuning in.